Hello everyone, it's Paul with Tutor U. I'm back after my long hiatus, and as you can tell, I look a little bit different than the prior videos. However, that's not important. I want to help you guys out with the GED length, volume, and area problems, so that's what we're going to work on today. If you guys need extra assistance, like personal help, like from me, go ahead and go to www.tutoru.com and contact me via my website. Let's get started on length, area, and volume. First off, let's define what the perimeter is. When you're talking about length, area, and volume, they're going to ask you questions about the perimeter of an object or a polygon or a shape. So perimeter, think of perimeter as just walking around something. It is the distance around the object. So if I told you to go walk the perimeter of your apartment or your house, you are walking outside, around the edge of it. And you have to calculate or find the distance of the perimeter. Okay? So it's just length around the outside of a polygon. How do you find the perimeter of this square? Well, or the rectangle, right? Well, it doesn't have any lengths yet, so I'm going to go ahead and add some in. Let's see if I can do that relatively quick. Let's say that this rectangle has a side of 4 and 1. And since this side is 4 and the rectangle has 2 equal sides, we know that the other side of the rectangle is also 4. This side is 1, so this side must be 1. And if we were to find the perimeter of this rectangle, we can go ahead and add the sides. And just think of it like you're walking around the outside. Okay? How far are you going when you're walking around the outside? Well, it is the 1. So 1 plus 4 plus 1 plus 4. And in other words, that is 1 plus 4 is 5. 1 plus 4 is 5. So that makes a total of 10. So maybe this is in meters or feet. We'll just say feet. So the perimeter of this rectangle is 10 feet. And you want to make sure you put your units if they give you something, if they give you the object in units. Okay? So pretty easy for this type of shape, but it can get a little bit more complex, and I'll show you how to do that. So here I have a little bit more of a complex shape for us to figure out the perimeter on. And if you notice, it's just this random type of shape. It's like a backwards 7 or an upside down L type of thing, right? But the core idea, I want you to remember the core idea that it's like walking around the outside. So we know this is 250 meters, this side over here. So we just walked around this side. Boom, 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 boom. Boop, boop, boop. So it is 250 meters. And this part right here is 30 meters. So let's start writing these down. So 250 plus 30. And then what is this part right here? Well, this is a rectangle, so this side must equal this side down here. So this must be 50 meters. So plus 50. This right here is 30 plus 30. And another 50 because of this part right here. So we have already walked around this entire part, and now we are just getting to this part, and this is where a little bit of math comes in handy. So what is the length of this part? Well, we know that this part here up here is 30 meters, right? So and this whole length over here is 250 meters, right? This whole length on this side. So 250 minus 30, because I'm taking this whole length over here and I'm subtracting this length over there. So that would be 220 meters. 220. So what does that equal? So 250 plus 30 plus 80, that's a lot of stuff. Let me just figure this out here. So it's 330, 360, 410, 630 meters. 630 meters is the perimeter of this shape. So if we were to walk around the outside of the shape, we would travel 630 meters. But we'll do one more perimeter problem. And with this one, the shape is a little bit different. So let's go ahead and just take a look. Remember, you are always going to be walking around the outside. So let's start off with the distance that we already have written down. And make sure to note that the unit is in feet. So we're going to start right here. Actually, we'll start right here. So we're going to walk across this whole area. And we have 50 feet. And then we're going to walk down. So then we have another 15 feet. Oh, I'm way off in the corner. I hope you guys can see. 15. And then we're going to keep walking around. Uh-oh. What is this length right here? We have to assume that this square here, right, is right in the middle. And that means that this length right here, or it's a rectangle technically, is 10 feet. Okay? And it's spot in the middle. So we have 20 over here. And another 20 over here. And that gives us the total of 50, because this top part is 50, and this bottom part is split up into 3 different pieces. So it is plus 10. I am so off in the corner. That's okay. And then it is plus 15. Plus 15. Plus another 10 down here as we walk around. Plus 15 as we walk around this outside. Plus another 20. It's not drawn to proportion apparently. Plus another 15, and we're back at where we started. It took us a little while, but we walked around the outside. So let me get that plus 15 down, and we can add these all together. What does this equal? Well, so 50 plus 15 is 65, plus 10 is 75, plus 15 is 90, plus 10 is 100, plus another 15 is 115, plus 20 is 135, plus 15 is 150. So 150, what's our units? Feet. So we have 150 feet of our perimeter. So if we were to walk around, it would be 150 feet. So roughly about somebody's yard. So I hope this helps you figure out how to find perimeter, kind of understand a little bit better of what perimeter is. And of course, if you need any extra help, make sure you go to my website. I'll put the link down below. It is www.tutoru.com. And if you would really like to help me out with everything, right? Like my massive thank you to me would be if you liked this video and you subscribe to my channel and help me grow. I would greatly appreciate it. But I appreciate you for watching this video. I hope you have a beautiful day, and check out the next video. I'll talk about area and volume. Hello everyone, it's Paul with TutorU, and today we're going to be talking about area problems that you might find on the GED. I'll give you the definition of area, and then we'll go through some example problems. However, if you need extra help, make sure you check out my website, tutoru.com. I'll put the link down in the description below. Otherwise, let's get started. Area is the amount of space that covers a two-dimensional figure. That's a very official type of definition, but basically, in the best way I can describe it is think of the amount of space that a carpet takes up. There's a certain length and a certain width, or a certain surface that it's going to take up, right? And so that's the best way to get initially warmed up to the idea of what area is. It's only two dimensions, so usually just length and width. Another very important aspect to your area is that the units of measurement. You always want to make sure you check your units of measurement on the GED because the questions and answers might have different units. It's an easy way to eliminate some of the possible answers that they're giving you. So the common units of measurement for area are your meters squared, your feet squared, and square miles, square kilometers, right? And so those are common terms that you'll hear or you'll read. So it's just a unit of measurement. If I say 10 miles, that's a unit of measurement. If I say 10 square miles, it's a different unit of measurement. It's talking about area. So let's go into an example problem. We'll start off with a very, very easy example problem, and then we'll move on from there. I'll start off with the area of a rectangle. So here I have this blue rectangle, and its length is 15, and its width is 6. So the way you find the area of the rectangle is to multiply the 15 times the 6, and that's how much space this blue area is taking up. So let's just give it a unit though. I want to make sure you guys keep that in your mind. So it's 6 feet over here and 15 feet over on this side. Oops, let's go FT for feet. And it is 15 feet times 6 feet. And once we calculate this will give us our square feet. So what is 15 times 6? You can go ahead and pause the video if you need the time, but it is going to be, I'll show you how I multiply. So 6 times 10 is 60, plus 6 times 5, and that is 30. And my answer to this problem is 90 square feet, and the way I'll write that is feet with a tiny 2 up there. So that's square feet. So 90 square feet is my answer. Now, I know you're probably thinking that's a very easy example, Paul. However, I'm going to move on to way more complex examples here in the next one and the one after. We might even move away from rectangles a little bit, and we'll move into some unusual shapes. But let's get on to the next example. Here we have an unusual shape for finding the area. There's multiple shapes involved, so it's going to take finding the area of different parts and then adding them together to figure out the shape, or to figure out the area of the shape. You'll often see these types of problems on the GED where it's multiple steps to finding the area. If you're not taking the GED, this is still going to help you figure out how to solve area problems. So let's get started with this. Our first shape that we have here is this long one over here, right? Let's see if I can get a good pointer out. Yeah. So we have this side over here that's 250. We'll just call it 250 inches. Okay. So 250 inches by 30 inches wide. So we're going to write that down. We're going to write down 250 times 30. So 250 times 30. And that equals 7,500. And so that would be 7,500 inches squared. Inches squared. So this is inches, and these are inches. Okay. Then the next part is this square that we have right here. So this square, which we are given one side of this square, and it's 50. So to find the area of the square is just side times side, or side squared. So 50 times 50. And we'll write that down. So we have 50 times 50, which that would be, let's see, so that'd be 2,500. 2,500 inches squared. And when we add these two, 7,500 plus 2,500, we get 10,000 inches squared. And so this is just an example, right? So nothing is to proportion in this, but a good example for you to see a multiple step area problem where you have unusual shapes involved, right? So this is the combination of a rectangle and a square. You can get all different types on the GED, and whatever test you're looking at taking, whether it's the SAT, whatever, you're going to get some unusual area problems, I promise you. In this example, we've added an extra step. So it's not just a two-step area problem. There's going to be a third step with a little bit more algebra, math, everybody's favorite subject that's here watching this video. Hey, if you don't like math, hit the like button. And if you love math, hit the like button. So let's go ahead and, that's such a cheesy teacher joke, I'm so sorry. Let's go ahead and figure this problem out. So we have the square. All you have to do is break math down into the smallest pieces and take them one bite at a time. So here's our square, and that is 20. Our side is 20. And to find the area of a square is you just do side times side. So 20 times 20, and that is 400. Whatever units it's in, it is still square units. Then we move on to our larger rectangle. We're only trying to find the area of the blue space, but we still want to find the total area of the big rectangle first. So 70 times 50, and that equals 3,500. Now we want to find the area of the smaller space. So that is 50 times 15, and that would be what is that? That is 25, so that is 500 plus 250, so that is 750. See, even I can make little tiny mistakes. So we want to take the 3,500 and subtract the pink space. So we're subtracting the pink space. So 3,500 minus 750, that is, our new answer for that area is 2,750. And then we add the 400 of the square. And so our final answer is 3,150 square units. And so that's how you do a multi-step area problem. This is, I'm not going to say this is the most complex problem you're going to get on the GED as far as area goes. You're going to get more complex, which we will eventually get into those. So, my name is Paul. You just watched one of my videos with Tutor U. If you need extra help when it comes to the GED or tutoring or anything like that, make sure you check out my website. I'll put it in the description down below. It is tutoru.com, and then you click on Mind, because I actually have another section for body, but that's irrelevant to this video. However, I appreciate you watching my videos. I hope you hit the liked button, subscribe to my channel, help me grow. I would greatly appreciate that help. That will benefit me greatly, and it just takes a second of your time. I hope you have a beautiful day, and make sure you take things one bite at a time. Hello everyone, it's Paul with Tutor U, and today we're going to be talking about volume. So we're going to go over a couple of volume problems that you can find on the GED, and the questions are going to be very, very similar. So I hope this helps you study. If it does, make sure you like the video and subscribe for more content. It will greatly, greatly benefit me, and I appreciate every last bit of you. So let's get started on a volume problem. We have our volume problem. And this is a very common or very similar, you'll find these kind of questions basically on the GED, very similar to these questions. So if this figure is the top view of a storage container that is 30 feet deep, what is the volume of the water tank? And you might recognize this figure from one of my prior videos where I went over either perimeter or area. If you haven't watched those, I highly recommend that you check them out. So how do we figure out the volume of this shape? Well, as you can tell, I split it up into two parts. So we have the top part of this water tank that is 60 by 15, and then it's 30 feet tall. So just think of this as like there's like a wall here, okay? And this wall is 30 feet tall. Boop. Boop. Okay, so this is 30 feet up off of the ground, the height of it. But let's just get right into it. The first thing that you still want to do with this problem is find the area of this 60 times 15. So it is 60 times 15 times 15, and that equals 900. And then you want to multiply the 900 times 30. So 900 times 30, and that equals 27,000. Okay? Now we want to move on to our next part. So our next part, so part 2. I can draw this kind of maybe in 3 dimensions. We'll see how this turns out. Alright, not too bad. I still have it, kind of. It looks a little bit weird. It looks like it's hanging off. But we have 20 times 10, and so that is 20 times 10, and that equals 200. Not too difficult of a math problem there. So 20 times 10 is 200, and then you do 200 times 30, and that equals, so what is 200 times 30? That is 6,000. Bum, bum, bum. So we have 6,000. So those are our two parts, the volume of those two parts. So we must add them together now. So what is 27,000 plus 6,000? Well, it is 33,000. So the volume of this area is 33,000, but remember, volume, your unit of measurement is cubic units. So cubic units, or units cubed, whatever you prefer, kind of. Cubic units. So if this was in feet, it would be cubic feet. If this was in meters, it'd be cubic meters. The way of thinking of this, so like the other units that you might see, it'd be like an M for meters and a 3. And then it might be FT for feet and a little 3 there. And that is our first example problem of finding the volume of an irregular shape. Let's go on to another example problem. Sometimes on the GED, they'll give you the cubic feet. They'll give you the total volume of the shape, and they'll ask you another part of the shape, like the height, the length, or the width. So here is our next example problem. We have a rectangular prism, and it has a volume of 600 cubic feet. If the length is 20, which I have right there, and the width of it is 15. Oh, my hand disappeared. What is the height of the prism? So we want to figure out the height. Always just write things down. If you can draw it out, I highly recommend that you do, but the key to all of this is writing everything down. So let's go ahead and write down what our problem really is. So we have this rectangular prism. So how do you find the volume of a rectangular prism? Well, it's length times width times height. So length times width times height, and that equals volume. And what we are given as far as our units, what we have 20 for our length times 15 for our height times h, and that equals 600 cubic feet. So how do we figure this one out? Well, it's about it's like a 1.5 step algebra problem. So what is 200 times 15? Well, that is 300. So we have 300. And instead of writing this times here, I'm just going to write the h. So we have 300h. And that equals 600. Then we divide. So what's the opposite of multiplying? Well, the opposite of multiplying, that's what's occurring between the 300 and the h. So the opposite of multiplying is dividing. So we divide both sides by 300, because whatever you do to one side of the equal sign, you do to the other. What is 300 divided by 300? Well, that's 1. So it cancels itself out. And 600 divided by 300, well, 300 goes into 600 2 times. So the height, h, equals 2. So the height of this rectangular prism is 2, and then don't forget your units, 2 feet. So we have 2 feet. So this is actually a pretty short, small prism. But the questions can get a little bit tricky if you don't write everything out. If you write it all out, you're going to be just fine. So take a screenshot of this, try to work it out with different units, just practice the problem. The more times that you do it, the better. Let's see if I can find another example for you guys. Our next volume problem, all they are doing is giving us the volume of a cube. They say a cube has the volume of 27 cubic feet. What is the length of its base? So how do we first start off this problem? Well, how do we find the volume of a cube? Right? So all sides are equal on a cube. So the way to think of it is, let's get everything all set up. So the way to think of the problem is similar to this. So a cube has all sides the same. You're finding the volume, so it's 3 dimensions. So it's side times side times side. That equals volume. And all we are given is 27. So side times side times side, and that equals 27 cubic feet. Don't forget your measurements. So 27 feet cubed. Okay. So what times what times what is 27? And that same thing, it has to be the same number. Another way of doing this problem is by using your calculator and calculating the cube root. So what we're really asking is the cube root of 27 equals s. So it has to be the same number, okay? So just think. So 2. So what's 2 times 2 times 2? Well, 2 times 2 is 4, times 2 is 8. So it's not 2. What about 3? 3 times 3 is 9 times 3. is 27. So the cube root of 27 is 3. And in other words, 3 feet is our answer. So the base here would be 3 feet. And since it's a cube, all sides are the same length. So 3 feet, and etc. You can go around and label it all yourself. If this video has helped you out, make sure you like, comment, and subscribe to my channel. I greatly appreciate it. Every last one of you. I hope you have a beautiful day, and I wish you really good luck, and I hope that whatever you're studying for, this helps you out. If it did, put a comment down below, and I'll see you later. Hello everyone, it's Paul with Tutor U, and today we're going to be going over the definitions of mean, median, and mode that you might find on the GED. If this video helps you out, make sure you like, comment, and subscribe. It would greatly benefit me, and I appreciate every last one of you for watching this video. So, let's get started with mean, median, and mode. What is the mean? The mean is the average value of a data set. That sounds a little bit crazy, it sounds unusual, the words might confuse you, but I promise you it is not too difficult. Once you get a few examples under your belt, you'll feel much more comfortable with finding the mean of a data set. So let's do a couple of examples of finding the mean of a data set. So what is a data set, first off? Well, it's just a group of numbers. So let's just start off with something very, very nice. And we'll start off with the example of, here, this is our data set. Oh, let me make this a little bit thicker. That's what she said. So a little bit, there we go. So our data set will go 1, 2, 3, 4 for our data set. And we want to find the mean of 1, 2, 3, 4. So how do we do this? Well, we find the average, so we add each part up. So 1, 2, 3, 4. So what is 1 plus 2 plus 3 plus 4? Well, that is 10. And then we divide it by the numbers inside of the data set. And so 10 divided by 4 is what? So 10 over 4. That is equal to 2.5. It goes in there 2.5 times. So 2.5, or another way of writing it would be like 2.5. So 2.5 is our mean. The symbol for mean is, it looks like a fancy M. So mean equals 2.5. So that's our first example of the mean. Let's do a couple of more. Here we have an example problem that's very similar to what you might find on the GED for something when it comes to finding the mean. So they give you this data set. They give you this group of numbers. And it says that the owner of Ice Cream Palace listed the number of milkshakes sold each day for 1 week. And it goes through the days of the week and how many milkshakes were sold at that place. So on Monday, there's 22, 16 on Tuesday, 20 on Wednesday, and so on. It's good to write all of this down. Write just the numbers down. Okay? So that's what I'm going to start off by doing. There we go. I will write down the number of milkshakes sold each day. So we have 22, we have 16, 20, 26, 24, and 85. Now, just like the problem before, the question is, what value best describes the number of milkshakes sold at Ice Cream Palace on a typical summer day? That typical summer day is finding the mean. It's finding the average summer day. So typical summer day is the same as average summer day. So what you do is you're going to go through and add all of these values here. So we have 22 plus 16, that is 38, plus 20 is 58, plus 26 is 84, plus 24 is 108, plus 85 is 193. So our top is 193, so this equals 193. And how many values do we have? We have 1, 2, 3, 4, 5, 6. So we need to do 193 divided by 6. And give me 1 second. I actually need a calculator on this one. So after consulting my favorite consultant, Siri, I have figured out that the answer to this, 193 divided by 6, is 32.16. So the mean value, the average value of milkshakes sold on a typical summer day is 32.16 milkshakes. They might have you round down and call this just 32 whole milkshakes, right? Because you're going to sell them. Technically, I mean, with it being above 32, I guess it could be 33 milkshakes sold, and that one person didn't finish theirs. But 32.16 is going to be your answer for the number of milkshakes sold on a typical summer day. Let's move on and find another example problem for you. So here we have our next example of a mean question, and it is a little bit mean, but a mean question that you'll find on the GED. It says we get this diagram, which is our data set of numbers, and it's Sneaker World sales for the week. So they have your days of the week along with the sales of each day of the week. The question is, the mean sales for this 1 week were $4,443. The manager misplaced her records for Saturday. What were the sales on Saturday? So we are given the mean, and we are asked to find out what a single day of sales is. This one is a little bit more complex, and I would highly recommend that you pause the video and you write all of this down. Just have it down in your notebook. It'll be there for you to reference later on. If you don't have a notebook handy, just follow along the best that you can, because I'm going to have to actually get rid of this text right here, and I will write out the problem on how to solve it. Okay? It's going to get a little bit messy, but I'll do my best to make it as clean as possible. So let's get started on working this problem out. So the very first thing that we want to do is just like any other question of finding the mean. So let's write out all of our data points as if we're going to find the mean. Okay, so we have the 5,000. Let me make sure I get everything all nice and set up for you guys. So we have our 5,229 plus 3,598 plus 6,055 plus 3,110 plus 3,765 plus the question mark. Don't forget the question mark, okay? And just like the other mean problems, the other average problems, you have to divide all of this by the total number of numbers, right? So we have 1, 2, 3, 4, 5, 6 numbers. So divide by 6, and that will equal the mean that we were given earlier, which, if you don't remember, it is 4,443. Double check. I'm good. So it is 4,443. Now, how do we go about doing this? Well, the first thing I would do is add all of these numbers up. So when you add all of these numbers up, you get 21,000, and might want to pause, keep up with me, 21,757. Double check that. Yep, 21,757. You don't have to do it by hand unless your battery dies in your calculator while you're taking the test. But 21,757 plus the question mark, all divided by 6, and that equals 4,443. Now, we have this stuff here. On top being divided by 6. How do we get rid of this division? Well, what's the opposite of dividing? It is multiplying. So we want to multiply that 4,443 times 6, and that equals 26,658. Okay, so let's rewrite this really quick, and it'll be a little bit easier, just a little bit. So we've gotten rid of that 6 on the bottom, remember that. So it is 21,757 plus the question mark, and that equals 26,658. So our next step is to subtract 21,757 from both sides. What you get on one side, or what you do to one side, you do to the other. So subtract 21,757 from this side. So this side over here, this cancels out. And what we are left with, we have our question mark is equal to, so what is 26,658 minus 21,757? Pause the video, give yourself a couple of seconds to work it out, and your answer should be 4,901. That is the missing value. So Saturday's sales value, is equal to 4,901. And what does this teach you? It teaches you not to lose your records of sales, so you have to calculate it backwards. But I hope this helped you understand the mean a little bit more, and it gave you an idea of what types of problems you're going to be facing on the GED. If this video helped you, make sure you like, comment, and subscribe. I would greatly appreciate it. I hope you have the best of luck on your GED, and I'll see you soon. Hello everyone, it's Paul with Tutor U, and today we're going to go over the definition of median. We're going to do a few example problems, and I'm just going to overall help you out with understanding what median is when it comes to the GED, statistics in general, high school type of stuff. I want to help you get a better understanding. If you need any extra help, make sure you check out my website, www.tutoru.net. So let's get started with our first definition of what a median is. To define median, it is the middle number in a set of data when values are ordered from least to greatest. Okay, a lot of fancy math words there, but basically you have a group of numbers. You want to put them in order from the smallest to the largest, and whatever number is in the middle, that is your median. So let's just do a nice easy example, right, to get the understanding down, and then we'll move on from there with some more difficult examples. So let's just go with 29, 17, 34, 55, and 100. So as you can tell, oops, they're not in order from smallest to largest. So we need to rearrange things, and it looks like only 17 and 29 are out of order. So we go 17, 29, 34, 55, and 100. And then we figure out which one is in the middle. So 1, 2, 3, 4, 5. So it looks like this one is in the middle. So we have 2 on this side, 2 on this side. So the median number in this data set, the median number is 34. That's the really easy, nice example. But the idea is it's the middle number. Let's take a look at what happens if we have an even data set. We have an even amount of numbers in our data set. So we'll just make up another data set. I'm just making this up on the fly from my head. Let's go with 25, 26, 28, and 100. And I listed them in order so we don't have to redo them. But if you notice, we only have 4 numbers in our data set. Okay? So how do we resolve this issue? How do we figure out what the median number is? Well, you take a look at where the middle should be. And the middle should be in between 26 and 28. So you take the average of those two. But we already know what it is. It is 27. Otherwise, you'd have to add the 2 numbers. If it wasn't evenly spaced like this, you'd have to add the 2 numbers and then divide by 2 to figure it out. But in our case, the median is 27. All right, so that's it for the nice, easy example. I hope that you got the main idea down of what the median is in a data set. Let's move on to some more challenging examples. When you take the GED or the ACT, you're going to get a lot of things like this. You're going to get a lot of tables, and they're going to ask you questions about the table. In this instance, it's times for the 100-meter race, and they give you a list of names, and they give you a list of times. So, our question is, what is the median time for this race? Well, what we're going to do is we're just going to put them in order. You don't necessarily have to write them all out, right? What you can do is go ahead, and we're just going to mark this table up. So, which one is our lowest number? Well, it looks like 11.8 is our first number. Oh, need to make it a little bit bigger. So this one is number 1. There we go, number 1. And then it moves on to 12.1, so that one is number 2. 12.6 is number 3. 12.8 is number 4. 13.5 is number 5, and number 6 is 15.2, and then 16 is 7, and then it is 8. Right away, I notice that we have an even number in our data set, so we're going to have to take the average of 2 numbers. So if we look at this, let's list these out now. Now that we've put them in order like this, let's go ahead and just list them out. It's easier to see things. Always write things down. Use writing as your advantage. As you can see, I have ordered them from least to greatest, and I've typed them all out just so it's a little bit easier for you guys to read instead of having to read my handwriting. I'm still getting used to my digital pad. So what we're going to do next is we're going to just put those numbers again down from least to greatest. So 1, 2, 3, 4, 5, 6, 7, 8. And the reason why I do that, it's to just double check myself, right? If I catch any errors, the more times that I'm repeating these things, the easier it is to find mistakes. And it's really great for you to do that on the GED test as well, or any of your tests. Write down as much as possible because you'll find more errors. And they give you a pretty good amount of time. So our middle number, our median, should be between 12.8 and 13.5. We have that even numbers. We have even number of numbers in our data set. So how do we resolve this? Now, you remember, we have to add these two numbers together. So it is 12.8 plus 13.5. And so we have to take the average of the two. So we divide by the numbers that we're adding together. So we have two of them. And what we end up getting is, so what's 12.8 plus 13.5? That is 26.3. 26.3 divided by 2. Okay, so 26.3 divided by 2, what is that? That is 13.15. And 13.15 seconds, don't forget your units, 13.15 seconds, that is the median time for this race. So now that we have the median time, we can go ahead. I'm going to move on to another example just to get you guys the most out of this video. So at this point, I'm going to say, if this helped you out at all, hit the like button. And if it didn't help you out at all, hit the dislike button, because I actually get to see how you guys are responding to my videos. If it really, really confused you, I really would love to either have you comment down below or reach out to me via my website. But let's move on to the next example. For our next example, I'm using a data set that I did in one of my other videos where I described the mean. If you haven't checked it out, make sure you check out my channel, and you'll be able to learn a little bit more about what's going on with statistics, mean, and then now we're doing median. And my next video will most likely be talking about mode and range of a data set. But let's figure out what the median of this data set is. So the owner of the ice cream palace is listed the number of milkshakes. Oops, I forgot to change the word number again. Sold each day for 1 week. We have 22, 16, 20, 26, 24, and 85. So let's just go ahead and list these out from least to greatest. So we have, let's get this all situated. So we have 16, 20, 22, 24, 26, and 85. So in this example, it doesn't really matter too much that we have this large 85, right? But what we really care about is which one is right in the middle. So 1, 2, 3, 4, 5, 6. Okay, so we have another even number in our data set, an even number of points inside of our data set. So what we must do is find the middle two, which would be 22 and 24, and we're going to add them together. So we get 22 plus 24, and then to take the average, you divide how many numbers you added. So we divide by 2. So 22 plus 24, that is 46, divided by 2, and that equals 23. And yes, I knew that 23 was perfectly in between 22 and 24, but I want you to get used to the process, right? Even if it's easy, I want you to be able to breathe how to find the median, right? That's how you do very well in math. You keep doing it over and over and over again until it becomes second nature. However, I'm going to cut this video short here, and I hope that this helped you out. If it did, I would really appreciate a like, subscribe, and if you're feeling really overly confident, go ahead and hit that comment button and just let me know that this video helped you. Otherwise, I hope you have a beautiful day. Hello everyone, I'm Paul with Tutor U, and today we're going to be talking about mode and range, some additional topics in the statistics section of the GED. If you need help with some of the other topics, make sure you check out my other videos, but today we're just going to go over the definitions of mode and range, and then we're going to go through some example problems. So let's get started. Let's start with mode, the value that occurs most frequently in a set of data, like what it says up here. But to put it in layman's terms, to put it in normal terms, it's the number that shows up the most in your data set. So if something shows up multiple times, keep a mental note of that as being your mode. So let's get a data set up on the wall up here. So yep, now we have a data set, and it's 23, 24, 24, 28, 30, and 75. But which one is the mode? Well, as we can see, the number 24 appears 2 times. So right here and right here. So to label it, our mode is 24. So mode equals 24. Now, in the next example, I'll just define range. So we have that down. To define range, it is the difference between the greatest value and the least value in a set of data. So I know that the language of all of this stuff can get a little bit overwhelming, but basically you take the biggest number in your group of numbers and subtract the smallest number, and you're given the range. So let's take a quick look at a data set. Let's get another one up on there on the wall. What is the range of this data set? So what you do is you take 75 minus the 23, and you are left with 52. So 52, so range is equal to 52. So it is the greatest number minus the smallest number. So what is the scope, beginning to end? What's the big difference between those two? That is a way to think of range. Now let's get into some more complex examples and see what types of questions you might be facing on the GED test. All right, so here we have a table. Always read the title of your tables. So here it says heights of relay race runners. And it has a list of names and a list of heights. We don't know whether it's in inches or what. I could only assume it's in inches because any other unit is going to be a little bit odd for any type of runners. However, it's always good to check. So our first question that we have is, what is the mode height of the runners? So what I'm going to do is I'm going to look through that right column, and I am going to see which ones show up the most. And right away, I start to notice that we have a double at least. So we have 65 there. We have another 65 there. And we have another 65 there. So the mode height of the runners is 65. So let's go ahead and we'll write that down. Go ahead and write 65 underneath there. So what is the range? So the range of heights, I see that the largest height or the greatest height out of all of the runners is 72. So we have 72 right here. And what is the lowest height? Well, the lowest height looks like it is 63. So what we have to do is 72 minus 63, and that is going to equal 9. So the mode is 65, and the range is 9. Not too bad for this type of thing, right? And these types of questions, you're going to get them a lot on the GED. You'll probably get some of them on the ACT. Don't overlook things. Even if it seems simple, always take your time, write as much down as you possibly can within your allotted time period. But yeah, let's take a look at a couple of more examples. Here we have another table, and like I said, the GED likes to give you tons of tables that you have to extract information from. So let's go ahead and read the title of this. It is the owner of Ice Cream Palace listed the number, forgot the ER in number, of milkshakes sold each day for 1 week. And we're given a set of numbers of data, and we're asked what is the mode and what is the range. So we can see that all of the numbers are different. So what does that mean about mode and the frequency, right? You're supposed to find the most frequent number. So in this, we have no mode. No mode. Nothing shows up more than the other. Now, when we talk about our range of milkshakes sold in a week, we have our largest number, which is 85, and our lowest number, which is 16. So we're going to go ahead and subtract. So take the greatest number, which is 85, minus 16, and we get 69. Oh, that's a meme. So 69 is our range. So I can make the statement then at that point that the range of milkshakes sold in a week is about 69. So whatever number you sell on like Monday or Tuesday, most likely you're going to sell, there's going to be a range that straddles it, right? Like, so if you sold your least number on Monday, you can most likely expect at some point to sell 69 more, or statistically speaking, because of the range. Now, because an event occurred before, it doesn't mean that it's going to happen again, but that's how people talk in statistics. It's a probability because of our given data set. So let's move on to another example. So here we have another example, and yet again, another table. If you haven't noticed a common trend, data sets usually come in tables. Always look at your title. So daily sales of a business, and we're given the days of the week, along with a dollar amount that the business made every single day. However, our two questions that are important to us at this moment are, what is the mode and what is the range? If you notice, all of the numbers are different. So yet again, we do not have a mode. So we're just going to go ahead and write down no mode. If all of the numbers are different, write down no mode. And I know I am repeating myself and I'm beating a dead horse, but I want you to remember this because it's an easy point on whatever test you're taking. So no mode. And what is the range? So our range is the largest number, which is $6,055 minus the smallest number, which is $3,110. And that equals $2,945. That is our range. Boom, we have our range. Now I know that's easy, but let's just go through that. So I saw that this is the largest number on our data set, and our smallest number is right below it, 3,110. So when you subtract these two, you get the 2,945. Pretty easy. Mode and range are the nicest statistics problems that you can get. And after a certain period of time, I'll make a video where we're going to make a box plot. And we're going to use this mean, median, and mode along with your range, your maximums and minimums of a data set. If you don't know what those words are, I promise you'll learn them. Don't worry about it. And yeah, of course, check out my other videos. I have a whole bunch of them going over different parts of the math test for the GED. And it can also help you just learn this stuff. If you're in high school, college, you're taking the ACT, this is going to be a great help. However, I'm going to make this a very nice and short, sweet, simple video. I hope you have a beautiful day. If you liked this content, if you have any questions, comment down below, like and subscribe to my channel. It will help me out immensely. I'm putting all of this information out here for free. And if you need any extra hands-on help, go to my website, www.tutoryou.net/mind, and I'll be able to be your tutor. We can work together, which I would really think that is awesome. Otherwise, I hope you have a beautiful day, and I'll talk to you later. Hello everyone, my name is Paul with TutorU, and today we're going to be talking about probabilities. This will help you out if you're going to be taking the GED test, ACT, if you're in high school, any type of introductory statistics class. I am marketing most of my videos to GED students because that's what I used to be. I was a former GED instructor. If you like this video, I would greatly appreciate it if you hit the like button. And if you don't like it, hit the dislike button. I can still see it. Also, I do have my website, so if you need hands-on assistance, if you need a virtual tutor, I can be your tutor. So just go ahead, I'll put the link in the description down below. Otherwise, let's get started with an example problem. Before we get started with an example problem, I want to define or give you a loose idea of what probability is. And that is the chance of an outcome occurring during a specific event. So if you flip your quarter, if you have one nearby, there's a 1 out of 2 chance that it is heads. There is a 1 out of 2 chance that it is tails. Just to give you that loose initial idea of what a probability is. There are 2 types of probabilities. There is theoretical probabilities, and that's your in theory. So in theory, each time you flip a coin, you have about a 50% chance of flipping heads. However, that's not the actual thing that's going to occur. So let's go to the next probability. The other type of probability is actual probability. If you toss a quarter 10 times and get heads 6 times, the experimental probability is 6 out of 10, which simplifies to 3 out of 5. So to put it plainly or simply, it is what you're actually doing. If you are flipping a coin, you are recording your heads and tails, so this is your experimental probability. Now, if you're just writing it out, there's always the experimental probability of 1 out of 2 of getting heads on your quarter. I hope that clarifies the differences between experimental and theoretical probabilities. Now that you have all of this under your belt, we can get going with some example problems. One of the most common probability problems that you'll find on the GED, ACT, in high school, or any introductory statistics class is going to be the bag of marbles problem. In this one, we have a bag of marbles. There's 10 of them. It contains 4 striped marbles, 4 white marbles, and 2 black marbles. And I'm just going to ask you some general questions about them, such as, what is the probability of pulling out a white marble? Well, we have 4 out of, let me get everything all set up. Well, we have 4 white marbles. Okay, so this is what we are looking for. This is what we want. And on the bottom, we put the total number of marbles. So there's 10. And then you just reduce the fraction. So 2 goes into 4 and 10. So my end fraction is 2 over 5. So the probability of me pulling a white marble is 2 out of 5. Or we can write it as a ratio, like this. And we can also write it as a percentage, 20%. Okay. So not too bad. Now, what's my probability of pulling a black marble? So I only have 2 black marbles. This is what I want. So top number is what you want. Bottom number is total of your event. So up here we have black marbles, 2 black marbles. And on the bottom, we have 10 total marbles. So it's 2 out of 10. Reduce the fraction, 1 out of 5. Or 1 to 5. And lastly, it is, well, so 1 out of 5, that's half as much as 2 out of 5. So that is 10%. All right. So that's our first nice, easy example. I'm going to get into some questions that you're going to more often find on the GED now. However, like I said, it's still going to help you out whatever you're doing. I hope it does. If it is helping you, make sure you like the video, subscribe. I greatly appreciate it. If you need extra help, make sure you comment down below. Here is our first wordy example problem. It is another marble problem yet again, but this time it's more complex, as you can see by all of the beautiful words up here, right? Let me read this for you. This is very, very similar to what you'll find on the GED. So, in the first event, Mark draws a striped marble. He does not replace it. In the next 3 events, Mark draws 2 striped marbles and 1 black marble. He does not replace those marbles either. What is the probability that he will select a white marble on the 5th event? So, let's just gather for a second. Hold your horses. Pause the video. Read this a couple of times. Figure out what's going on. I'm going to work through it. What I'm going to do with this problem to make it easier, just forget about all of that stuff. Let's first list what marbles we have in the bag and the probabilities of them, okay? So we have, in the bag, we have our 2 black marbles, okay? We have 2 black marbles, so that's 2 out of 10, so that's black. We have 4 white marbles, 4 white. And we have 4 striped marbles. And that is also out of 10. Now let's reread this problem. In the first event, Mark draws a striped marble. So that means that we got rid of one of these. And now this is down to 9. And this is also down to 9. We've thrown out the marble, okay? In the next 3 events, Mark draws 2 striped marbles. So now we're down to 1, and 7, 7, 7. And 1 black marble, 1. He does not replace any of these marbles. What is the probability that he will select a white marble on the 5th event? Well, since we've done it this way, the answer is right here. So, the probability of him pulling a white marble out of the bag on the 5th event is 4 out of 7. And we can write that as a ratio this time. Or you can write it as a fraction. 4 over 7. That is a funny looking 4. All right. It's a lot to digest. Take it in. And we're going to move on to the next example problem. So we've moved beyond the marble problems now, as you can see, because we have a spinner. Spinners are one of the other favorite things in statistics and probability, just to kind of help confuse you, right? Well, I mean, it's not to confuse you, it's to make sure that you're learning the material. So it says Maude uses the spinner to conduct a probability experiment. So what we're going to do is we're going to spin the spinner. I'm not actually going to spin it, but we'll get it all figured out. We're going to list all of the probabilities out, and then we're going to answer our questions. The probability of landing on 1 can be written as, well, we have 1, 2, 3 ones. And there is 1, 2, 3, 4, 5, 6, 7, 8 possible zones to land on, right? So we are 3 out of 8 for landing on a 1. So landing on a 1. Okay, what about the probability of landing on a 2? Well, there's 3 2s in the spinner. So that is 3 out of 8 for landing on the 2. I'll just put that here. Now, what's the probability of landing on a 3? Well, we only have 2 of them, so 2 out of 8, or let's reduce this down so it is 1 out of 4 for landing on a 3. Now that we have all of that written down, let's look at a question. On the first spin, what is the probability that the spinner will land on an odd number? Well, when we look at it, we have our probability of landing on 1, which is 3 out of 8, and our probability of landing on 3, which is 1 out of 4. You have to add those two fractions together. The nice part is I still have the 1 out of 4 written as 2 out of 8, so we just add the 2 and the 3. We get 5 out of 8. So the probability of landing on an odd number is 5 out of 8. We have added our 3 and our 2 here, our non-reduced fraction, our not simplified fraction. We've added those two together because they have the same least common denominator, and that gives us our probability of 5 out of 8. It can also be written as our 5 out of 8. That is the first question dealing with this spinner. Now we have our next question, which is on the second spin, what is the probability of the spinner landing on a 1 or a 2? And this is why I have written out the probabilities before even going to the questions. You know that it's going to be a probability-based question, so write out all of the probabilities first. That way, it's a lot easier to do this stuff. So we need to add the probability of landing on a 1 and the probability of landing on a 2. And that is 3 over 8 plus 3 over 8. And that equals 6 over 8, or in other words, that is 3 out of 4, the reduced fraction. So the probability of landing on a 1 or a 2 is 3 out of 4, or about 75, not about, it is exactly 75%. So I hope these questions help you better understand probabilities, the marble problem, the spinner problems. These are very, very common on the GED. And if you want to help support me, make sure you hit that like button, subscribe to my channel, and I'm going to be posting a lot of content. If you need extra hands-on help and you're just not getting it, make sure you check out my website, tutoru.net/mind. I'll put the link down in the description. Otherwise, I hope you have a beautiful day. I greatly appreciate you watching my video. Hello everyone, it's Paul with TutorU, and today we're going to be going over line graphs, bar graphs, and scatter plots. I hope this helps you study for the GED, and if it does, make sure you hit the like, comment, and subscribe, because all of those things help me get this information out there to more people that could use the help. I hope you guys have a beautiful day, enjoy the video, take your time, and study hard. For this first graph, we have what's called a scatter plot. What scatter plots are used for is to show a relationship between two different types of data. In this one, we have hours and percent correct. So this is study time for the GED math test. If you look up there, it has the title. When you look at these graphs, you always want to read the titles and different labels. So what we have is study time for GED math test, percent correct, and over there, the hours. And as you can tell, there is what is called a correlation. So a correlation is the definition of a relationship between two different types of data. What this is showing is a positive correlation. It's moving up from left to right. What you'll most likely run into on the GED when you're looking at any type of graph are questions in regards to, like in this one, they're going to ask you, how many hours do you have to study to get a certain type of score? So let's just kind of go through that. How many hours would you have to study to score an 80%? Let's circle the area right around that 80% mark where most of the scatter points are at. So if we look over here, we have the 80% and everything seems to be circulating right around this. We have the most data points in this area, around 80%, and it looks like I look down at the number of hours, and it looks like we need to study for 6 hours to score an 80%. If I asked you how many hours do you have to study for the GED math test to score a 90%, you go ahead and you look at the 90% mark, the 90% line, and you follow it over. And it looks like we have 3 different data points, but it looks like the ones that will guarantee us or nearly guarantee us a 90% would be this zone right here. And that is at 9 hours of study. So if you want to score a 90%, you're going to have to study for 9 hours. Scatter plots are pretty nice. It's a really nice tool to show trend lines. And like I said, positive correlation, that is moving up from left to right. That is a positive relationship between percent correct on a test and number of hours studied. Now we're moving on to the next type of graph, and this is what's called a line graph. Line graphs typically show a relationship between some data point and time. In this example, we have our dates or our months of the year, and up here we have inches of rainfall. When we look at the title of this graph, it says monthly rainfall in 2 state parks. So what we're going to be doing is comparing the rainfall between two, maybe not national, it says state parks. That's why I read it. However, we can look at it and we see that there are 2 different colored lines. Each one represents a park that they are measuring the rainfall in. The blue line is Park A and the orange line is Park B. And it goes over the course of 6 months. Another thing to make a note on is with line graphs, you can have multiple entries of data. So here we have 2 state parks, but we could have 3, 4, 5 different state parks, or we can compare all of the national parks in a line graph. That's why they're so useful, is that you can compare multiple entries to each other. In what month is the biggest difference in rainfall between these 2 state parks? This is the type of question that you're going to get on the GED. So when we're looking at here, over there, right? It looks like April has the biggest gap. And we can tell by, if you don't get those lines in between, you can draw them in between. It just looks to me that April is the biggest gap in rainfall between the 2 state parks. What month has the smallest gap in rainfall between the 2 state parks? Well, it looks like May. So let's move on to our last example of a type of graph that you might see on the GED. Here we have what's called a bar graph. A bar graph is another tool used to compare 2 different types of data. And here, in this example, we are comparing contestants along with the distance that they have in the long jump competition. As you notice, there are different colors representing the different contestants, and they stretch across the graph representing how far they did their long jump. Always read your title and your different labels when you're studying for the GED and when you're taking the test. Now, I'm going to read off a few questions that you might find on the GED test, and this goes as far as your social studies test or math test. So for my first question, go ahead and pause after I say this, then take a look at this graph and see if you can tell. So, what contestant jumped exactly half as far as the contestant winner? Go ahead and pause the video now. Alright, so the contestant that jumped exactly half as far as the contestant winner, well, here is the winner right here. They jumped the farthest out of everybody. And the person that jumped exactly half as far as them is this person, contestant A. So we'll put a circle, or you know what? They get a star. We'll put a star on contestant A's bar graph. For our next question, it is Katie and Elena jumped the exact same distance. Put a mark on the bar graph of the 2 contestants, Katie and Elena. Go ahead and pause the video. Alright, so that would be, all you have to do is just take a look at the bar graph and find out. Or take a look, here, see? We have this person right here and this person right here. They jumped exactly 15, we'll assume feet, unless you are Superman. And that's how we know that this is Katie and Elena. Another type of question you'll find on the GED is just proving that you're reading the question thoroughly. And that question will be something like, put an X on the contestant that disproves the statement that no one jumped farther than 15 feet. So, pause the video. Okay, this one is pretty obvious. Well, there are two contestants that jumped farther than 15 feet, and that is the blue contestant. Oh, I suppose I didn't read it properly. I didn't put an X. So we'll put an X right here. Contestant G jumped farther than 15 feet, and contestant D jumped farther than 15 feet. However, I'm not going to put an X on the yellow bar or this tan bar, because they didn't jump farther than 15 feet. They just landed right on it. So we've put our marks down here and here. That answer, or that question, is now complete, and we'll move on to the next question. Another way they're going to test your knowledge is to use different vocabulary words inside of the question. So for an example like that, I'll say something like, contestant C significantly improved his next long jump attempt. In fact, he tripled it. So go ahead and mark on the graph how far that contestant C has jumped now. Go ahead and pause the video and take a look, and take a mental note of how far they would have jumped if we tripled contestant C's distance, and I will go ahead and I will mark it. Contestant C only jumped 5 feet. So if you tripled 5 feet, how far did you go? Well, you have now successfully long jumped. You have successfully long jumped all the way out to 15 feet. So you are now tied. You are now tied with contestant E and contestant B. There we go. And the last question will be something like, contestant D significantly faulted on his next attempt, or on this attempt, and so he had to revert his distance back to the prior attempt's length of 17 feet. Go ahead and mark on the graph where 17 feet would be on contestant D's jump length. Well, it would be right in the middle. And the reason why I know that is this is 15 and this is 20, and 17 is roughly right about in the middle. I guess we could technically put it right in here, and that would be okay. And so this distance would not count anymore after that question is asked. I hope all of this helps you study for the GED. If you have any additional questions, go ahead and put them down in the comment section below. I am going to start doing some live classes that I'll air at 9 a.m. Central Time. If you want some extra help, swing on by. If you need immediate assistance on different types of topics, check out my website, www.tutoru.com/mind. I can be your personal tutor. Otherwise, I hope you have a beautiful day, and I appreciate you watching my video. Hello everyone, it's Paul with TutorU, and today we're going to be looking at circle graphs. By practicing the skill of interpreting circle graphs, you're going to improve your test-taking and studying abilities for the GED math test. Let's get started with some examples. Here is our first example of a circle graph. The main thing I want you to remember when you're interpreting the data of the circle graph is that it represents the whole. So you're comparing small pieces of data with their relationship to the entirety of everything. So as we see here, this is Jerry's budget. We are comparing school supplies, car maintenance, gasoline, food, other, and clothing. So Jerry, some guy off of the street, probably somebody pretty smart if they're putting their budget into a circle graph, he is comparing his monthly budget to other items that he spends money on. So the entirety is Jerry's budget, and a percentage is food, and another percentage is gasoline. This way you get a visual representation of the whole budget, that is Jerry's. Here we have our first question relating to a circle graph, and it says approximately how much per month does Jerry budget for food? We can see here that food is the largest out of all of the groups. Car maintenance and gasoline take up about half when they're added together, which means each one takes up about 25%. And food takes up just a little bit more than 25%. So which answer is it? Is it A, 10%, B, 20%, C, 30%, or D, 45%? Well, It's not quite 45% because that would be almost half. It's definitely not 10% because that would be too small. And 20% it's bigger than 20% because it's bigger than a quarter of it. So that means that the answer must be C, 30%. If you got that one right, I'd like for you to hit the like button. If not, that's okay. Let's move on to the next example. Here we have our next circle graph. The title of the circle graph is Sources of Tuition. And in this question, I'm going to ask you to kind of mentally play along with me, but they want us to label each section with the given percentages. So which percentage is financial aid of 45%? Well, let's go ahead and put that in its appropriate spot. Well, it looks like financial aid is the largest out of all four, and it looks like this blue area is the largest out of all of the sections on the circle graph. Our next one is salary, which is 30%. So where should we put the 30%? Well, let's see. I think it should be right here. Salary of 30%. This bronze-looking group is bigger than the silver and the gold group. Now we're moving on to scholarships, which is 20%. I think that the silver group is 20%. Oh, let me get that back over. Boom, there we go. Lastly, we have the parents. So parents are contributing 15% to this person's tuition money, which that would have been amazing for me. But let's take a look. So financial aid is 45%. Does that look right? Yeah. Salary, 30%. That looks about right. Scholarships, 20%. Sure, pretty sweet to get a scholarship. And then lastly, parents, 15%. But let's get real here. Most of it is just going to be financial aid and federal grants. So let's move on to the next question. In this example, the circle graph is representing how employees get to work. So the whole circle is employees getting to work, and it's broken up into sections. When we read the legend, it is walk, ride a bus, drive a car, or ride a motorcycle. Personally, that would be my preference, but it's way too cold out where I'm at. Let's get a question up on the board. So here we have our example question, and it's about what part of the employee population drives a car to work. Is it A, 25%, B, 30%, C, 50%, or D, 60%? So let's just take a look. The silver is drive a car to work, and that one is by far the largest. So your real question is it 25%? No, because it's a big portion of the whole. Is it more than half of the whole? Because C is half of the whole circle. And it does look like it's more than half of the circle. So the answer on this one would be D, 60%. I hope you got it right. If you didn't, and if you need more hands-on help, make sure you check out my link to my tutoring business in the description down below. If you guys are liking this video, I would really greatly appreciate it if you hit the like button, comment, let me know how this is going for you, and subscribe to my channel. Let's move on to the next example. In this example, a library has created a circle graph to represent all of the genres of books that people checked out last month. Let's take a look. So we have nonfiction, crime, mystery, romance, poetry, and classic fiction. I hope some of you like some of these reading genres as well. So this is all of the books that people have read in the prior month. The library has created this to better understand their population and to use it for ordering upcoming books. Let's take a look at the question that we have. Which category of books could a librarian make the best argument to order this August? So remember, the title is What People Read Last September. So the librarian is wanting to order books for the next year's August month, right? So is it A, nonfiction and mystery, B, mystery and romance, C, nonfiction and crime, or D, classic fiction and poetry? Take a second and pause the video. Let's work this out together. So pause now. Okay, so it looks like, would you want to do poetry and crime? No, those are the smallest groups on your circle graph. Same thing with romance and classic fiction. Those aren't the large groups. So you're trying to use the largest percentage of the circle to order books for the next year, right? That's what most people are reading out of the whole of the books checked out. So that would be nonfiction and mystery. Those are the two largest sections of our circle graph. So that would be the best argument to order for the next August. So your answer on this one is A, nonfiction and mystery. If this video has helped you out, I would greatly appreciate it if you hit the like button, comment, and subscribe. If it doesn't help you out, go ahead and hit the dislike button. I would really appreciate just having that feedback. If you guys want live math classes, I am doing live math classes Monday through Friday, 9 a.m. on my channel here. So just stay tuned for that. Otherwise, I appreciate you and I hope you have a beautiful day.